to review polynomials. Here's a video that hopefully includes the extensive amount of stuff that we have done so far this year in Integrated 3. So if I talk too fast, you guys know that you can slow me down. If I am too slow, go ahead and speed me up. You can pause at any point in time to either rewind or fast forward as well. So here's our need to know list. I'm going to go through some examples that are going to cover this need to know. And I'll probably have a couple of them wrapped together. All right, so let's go ahead and talk about the degree and the end behavior. Well, if you take a look at question number 1, we look at the way that it's set up and the type of setup that it is currently in standard form. Standard form being that every single term is separated from each other by addition and subtraction signs. So there's no multiplication of variables happening here. When we're trying to find the degree, you're going to look for the biggest exponent there is. And in this case, the exponent is 7. So the degree of this polynomial is going to be 7. All right, now in order to be able to talk about end behavior, we need to talk about the leading coefficient as well. So go back to the exact same term where you got the 7 from, and we can take a look at the coefficient there. So the leading coefficient in this case, although it wasn't asked for, we kind of need for this, is 2. And I don't particularly care if it's 7 or 19 or negative 2/3, that doesn't matter. I care about whether or not it's positive or negative. So since this is positive, this is going to tell me what the right side of the graph is going to do. So leading coefficient, right side of the graph. So if I talk about my end behavior at this point, I can say based off of the leading coefficient that the right tail points up. Now, depending on who your teacher is, they may decide that you can give them symbols to describe end behavior. As I've stated in my class, if you have me for your teacher, I expect you to describe it in words. Okay, now let's go back to the degree. The degree is going to help us figure out what the left side of the graph does as it relates to the right-hand side. So go back to the degree. If the degree is an even number, then that means that the tails are going to point in the same direction. If the degree is an odd number, which this one is, then we know that the tails are going to point in opposite directions. So now I can say the left tail points down. Okay, moving over to the second question. I went through and I got rid of the exponent on the 3x minus 1 because I did want to talk about something that wasn't an even power. So this one we have not in standard form, it's actually in factored form. I know this because I've got multiplication happening between the x's. So what I'm going to do is I'm going to find all of the exponents that belong to the x's themselves. So there's no exponent on the first x, which means there's technically a 1 there. And then you've got an exponent of 2, and then again another no exponent. So there's an exponent of 1. In this case, you're going to actually add those numbers together to get the degree. So in this case, the degree is going to be 4. And then the leading coefficient. All right, I'm going to go through, I'm going to figure out, if I were to multiply it out, not that you're going to, but if you did, what would you get on that x to the 4th term? So just take all the coefficients on the x's. So I've got a 4 coefficient here, a 1 squared coefficient here. So I've got a coefficient of 4, a coefficient of 1, and then I have this coefficient of 3. 3 to the 1 power is 3. And I would multiply all of those out, and that's going to give me a leading coefficient of 12. So in this case, since the leading coefficient is positive, I know what the right-hand side is going to do. So end behavior, I'm going to say that the right tail points up because of the positive leading coefficient. And then I'm going to take a look back at the degree. The degree in this case is an even number, so that tells me what the left side does. So the left tail, even number, which means they point in the same direction. So that's also going to point up. All right. Moving on to question number 3 for finding roots and x-intercepts. I personally like to find the x-intercepts first. So I go through, and you'll notice that both of these are in factored form. And in order to find the x-intercepts, you do want to make sure that it's in factored form, or go through the process of solving for x if you plug 0 in for y or g of x. So in this case, I'd take a look at each one of those factors themselves and find out what my x-intercepts are based off of that. Now, as a reminder, x-intercepts are always written as points. So for the first one, that would be a -4, so whatever makes the first set of parentheses 0, comma 0, and then 1, comma 0, and then 5, comma 0. Okay, x-intercepts written as points, done. All right, roots. Remember that another name for roots are zeros. So in this case, just take a look back at the x-intercepts. So just the values themselves. Ignore the 0 part. Those are your roots, but you got to make sure that you set them equal to x. So you get x equals -4, x equals 1, and x equals 5. Okay, the next thing that I'm going to do is I'm going to take a look at, back to the original question, figure out if there's any multiplicity. So go to where the -4 is located in the factor, and it's going to have an exponent of 3. If it has an exponent of 3, then you need to identify that as the multiplicity of that root. So I would say with multiplicity of, and the exponent, so I would put a little with there. Okay, go to the next one. So if I have x equals 1, go to where the 1 is located and take a look at that exponent. That exponent's going to tell me what multiplicity I have. So I would say with multiplicity of, and then there was an exponent of 2 on that. So I get a multiplicity of 2. I'm going to do the exact same thing. So find the x equals 5, and take a look at the exponent. Well, there's nothing there, and if there is anything there, it would be a 1. But multiplicity is something more than 1. So we don't say multiplicity of 1. So I'm not going to write anything for x equals 5. Okay, that's my x-intercepts and my roots. I still need to be able to find my y-intercept. As a reminder, to find the y-intercept, you're going to plug in 0 for x. So basically, everywhere you see an x, you're going to cram in a 0 into the problem. And then from here, go ahead and solve. I ended up with g of 0 being -640. Now you're not asked to plot points like this. That would be crazy. So, but do remember that you need to write it as a point. So you plugged in 0 for x and you got -640 for y. Okay, the next question, number 4, is just like this one. So now would be a great time to pause the video and then see if we get the exact same answers. Okay, so the only difference that I noticed here is that if you have an x-intercept that is 0, 0, it's the only place on the coordinate plane where it is both an x-intercept and a y-intercept. So if the x-intercept is 0, 0, guaranteed you've already found the y-intercept as well. You just need to make sure that you stated that. Okay, moving on to the next slide. All right, now there's another question like this on the following page, so I'm going to go through and do this one with you, and then just like we did on the previous problem, when I get to the next slide, I'll pause it. I highly recommend that you guys do as well and see if you can go through and do the problem. All right, so we have a whole laundry list of things that we need to be able to do. I think I'm going to do degree and end behavior first. So if I take a look here, I'm going to go through, I'm going to find the exponents on all of my x's since it is in factored form. Got a 2, a 3, and then there's nothing there, so remember that's technically a 1. All right, so my degree is going to be 2 plus 3 plus 1, which is 6. My leading coefficient, although it didn't ask for it, I am going to go through and figure out what the leading coefficient would be so I can figure out what the end behavior is. So take a look at the coefficients on the x's. They're all just 1s, so 1 times 1 times 1 times however many exponents you have is still just going to be a 1. So that's a positive number, which means my end behavior is going to tell me that with the positive sign, this is going to be that the right tail points up. And then since the degree is 6, which is an even number, that's also going to tell me what the left tail does. So I'm going to say that the left tail points, well, if it's an even degree, they both point in the exact same direction. And now to be honest with you, when I go through and I start graphing these problems, because I do kind of like jump back and forth between doing the work and graphing at the same time. Once I have determined what the end behavior is going to be, I go through and I just put little floating arrows on the graph. So if I go to the right hand side, I know that the right side is going to be pointing up. I also know that the left side is going to be pointing up. So this is just an indication as to where I need to start my pencil when I start graphing. Okay, back to it. All right, so we've taken care of, so let's check some stuff off. I took care of degree and I took care of end behavior. All right, let's talk about roots and intercepts. All right, I'm going to go ahead and find the x-intercepts first. So go back to each one of the factors that I haven't highlighted yet. So I'm going to go ahead and highlight those guys in blue. So actually I think I'll do yellow because that's what I did on the previous page. So I've got an x minus 4, and an x plus 5. So the x gives me 0, 0. The x minus 4 gives me 4, 0. And the x plus 5 gives me negative 5, 0. And then as soon as I find the x-intercepts, I go ahead and plot them personally. So if I plot 0, 0 as a point on the graph, 2, 3, 4, 0 as a point on the graph, and then 1, 2, 3, 4, negative 5, 0 as a point on the graph. All right, now once the x-intercepts are on there, I can go ahead and identify my roots. So I know that I have x equals 0, 4, and negative 5. X equals 0, x equals 4, x equals negative 5. All right, now I'm going to go back up to the problem, and I'm going to take a look at the exponents. So on the just plain old x, so x equals 0, I do have an exponent of 2, so I'm going to state with multiplicity of 2. And then take a look at the next one. So for x equals 4, the exponent on that 4 is a 3, which means I do have multiplicity. So I would say with multiplicity of 3. And then last one, find where the 5 is. The exponent is 1, so I don't state multiplicity here. All right, so have a better idea now of what the graph is going to look like as it's going through those points. All right, y-intercept, I think I got lucky again. So if you take a look back at your x-intercept here, I have a 0, 0, which means I already found my y-intercept. It is also 0, 0. One of the things that's nice about polynomials is that they are definitely functions, which means they're never going to have more than one y-intercept at a time. All right, let's see what else we can check off the list now. So I did roots, I did x-intercepts, y-intercept. Okay, domain and range. Domain with this, actually with any polynomial, which is kind of nice, is all real numbers, always. Now the range, I don't know, let's take a look at the graph and see if it's even reasonable to ask that question without having a calculator in front of me. All right, so here we go. I'm going to graph from left to right. So I'm going to focus on the very first x equals, well, from left to right is negative 5. So if I take a look at the negative 5, I'm going to go take a look over here at what's going on with negative 5. So at negative 5, there is no multiplicity, which means the graph is just going to go right through it. All right, so let's just go right through the graph at negative 5. Remember that my pencil has to start above the x-axis because that's what's happening on the left-hand side based off of end behavior. So I'm going to come in and I'm going to go down. And then I'm going to stop because I don't know what's going to happen next. All right, so now let's go ahead and take a look at the next one, which is going to be from left to right. I'm going to run into is the 0. All right, if I take a look at x equals 0, I have a multiplicity of 2. If a multiplicity of 2, that means that my graph is going to bounce on the x-axis at 2. So I'm going to pick up right where I left off here, and I'm going to bounce on the x-axis, and then I'm going to stop because I don't really know what's going to happen next. And then I'm going to go through, and I'm going to take a look at my next x-intercept, or my root, which would be x equals 4. If I take a look at x equals 4, it looks like I have a multiplicity of 3. If I have a multiplicity of 3, then that means that my graph is going to twist at that point. All right, so I think I need to bring this down enough so that I can go up. You want to twist there and then up. And notice that the ends of my graph are going in the same direction that I expected them to. Now, I don't know how low the bottom of the graph is going to go. So down here, and here, that was just an estimate. I'm not totally sure exactly how low they're going to go without a calculator. So now I think about the whole range thing. If I don't know how low those are and I don't have a calculator, I don't think the range on this question is reasonable. So I would go through, and it's not something that I would ask you if you didn't have a calculator. And then I think we've gone through and I sketched the graph. So it looks like I did all of the requirements that were necessary for this one. Okay, a question just like the previous page. So go through, follow all the directions, do what we just did previously. Now would be a great time to pause. I'm going to go through, pause, do all of the work, and then once you unpause, you'll be able to see the answers and see how you did. Okay, so here is the solution to this problem. If you go through and take a look at it, hopefully your work matches mine. Okay, moving on. One of the next things that we did was being able to write the equation of the polynomial in least degree, so we don't want to add any more additional work in, and we're going to go ahead and put this in standard form. So in this case, I'm actually going to leave question number 7 for you. I'm going to do number 8, and then, so I'm just going to kind of reverse these guys. So the first thing that I would do is, if I am given roots, is go ahead and rewrite them as x equals. So x equals 1/3, x equals root 7. Okay, now I'm going to go ahead and rewrite these as factors themselves. So I kind of need to like reverse my order on this thing. But before I do that, one of the things that's important to note, whenever you have a root here as one of the zeros or roots of the problem, remember something like that would come from the quadratic formula. So what you are going to need to do is make sure that you include its conjugate. So if you have the positive roots, remember this comes from the quadratic formula, so if there's no plus or minus in front of it, you're going to have to put the plus or minus in front of it. So we're also technically, although it wasn't outright given to us, we have to know that x equals negative root 7 is also an answer. All right, I'm going to go ahead and rewrite these as factors. So I'm going to eliminate this fraction here by multiplying both sides. Let's multiply this whole thing by 3 to just eliminate the fraction. So I'll get 3x is equal to 1, and then minus the 1 over. So 3x minus 1 is equal to 0. So one of the factors that I'm going to multiply is 3x minus 1. Then I'm going to go over here. There's no fraction to get rid of, so I'm just going to minus the root 7 to the other side. So let's go ahead and include that guy as one of the factors, and then add the root 7 to the other side on this one. So x plus root 7 is one of the factors as well. Okay, so this is going to be equal to f of x, g of x, h of x, y, whatever you want to call it. However, it's not in standard form yet, so at this point you're going to want to go ahead and multiply these guys. Now, whenever you have conjugates involved, so those two factors look almost identical, except for the sign is different, you're going to want to multiply those first. So if we multiply these, you're welcome to draw the box to help yourselves out. So if we want to draw the box here, we want to multiply x minus root 7 and x plus root 7. Something really nice is going to happen when you multiply these out. So I'll get a negative root 7, x on the outside, positive root 7, x on the outside. And then when I multiply negative root 7 and positive root 7, it's going to be negative. And then it's root 7 squared. Well, the square and the square root cancel each other out. So you're just going to get a 7. So here's the beautiful part I was talking about. If you take a look at that diagonal, those are going to cancel, which they should. So in this case, I now have 3x minus 1 because I haven't multiplied that out yet. And then from here, I have an x squared minus 7. Now, last thing you're going to want to do is multiply that out as well. So again, if you like using the boxes to help yourself out, let's go ahead and get that out. So then we're going to do 3x minus 1 and an x squared minus 7. And go ahead and fill those boxes in. That's not a squared, it's just an x. and then plus 7 there. All right, then from here, we're going to end up with our final f of x itself. So f of x is equal to, in this case, looks like we have a 3x cubed inside the box, a negative x squared, a negative 21x, and then a positive 7. So this is going to be our answer right there. Okay, so now the other question is just like it, except there's no roots involved here, so like square roots or cube roots. So you don't have to worry about creating the additional answer that goes with this. So now would be a great time to pause it, see if you can get the correct answers. And here's the worked out problem for question number 7. Notice that I didn't include any additional roots that weren't given to me already, and I didn't include conjugates. If there was like a square root, then I would have, but I don't have to in this case. Okay, the next concept that we started talking about, again, same type of thing except writing these things in factored form. So in factored form might be a little bit easier. In this case, you want to see, so we're kind of relating it back to stuff that we did previously on this already. And take a look at all of these x-intercepts. I know they're x-intercepts because they are comma 0, except that one is not an x-intercept. So we're not going to use that guy as an x-intercept. Well, every x-intercept can be written as a root. Every root can be written as a factor. So if I took this one, I get x equals negative 6. That's going to give me x plus 6 equals 0. X equals 2 gives me x minus 2 equals 0. And then this last one, x equals 4, gives me x minus 4 equals 0. So those are all of my factors here. So I'm going to have x plus 6, x minus 2, and then x minus 4. This other point, though, is not an x-intercept. Since it's not an x-intercept and it is just a point, then we're going to identify that as an x comma y. And we're going to plug it in as xy into our equation. So we'll get y is equal to, now the only reason I'm doing this is because I don't know what that leading coefficient is going to be. So I'm going to put in an a, just like we did when we did parabolas. So now let's go ahead and plug that point in. So I'll plug negative 13 in here. And then for all of my x's, I'm going to plug in negative 4. When we multiply out that side, we're going to get 96, and then go ahead and divide by the 96 on the other side. So it's going to be negative 13 over 96. So that's going to give us our a. Now what we need to do is just write the equation. It did say that we get to write this answer in factored form, so I'm not going to go through and actually multiply it out. So put the negative 13 over 96 in the location for the a, and then just continue writing down what we had for the factors. So x plus 6, x minus 2, and x minus 4. Now the next question is just like this one. One of the important things to note, though, is that we have this other point. So just remember that that is an x and that is a y. Then you're going to want to take a look at the graph itself and see if you can find out where the x-intercepts are located. And then just pay attention here because you've got some multiplicity going on. So if it were me, I would go ahead and pause the video, see if you can figure out what the multiplicity is. And remember, multiplicity gives you the exponents on the factors themselves. So see if you can get the question set up, and then maybe unpause it, look quickly, see if we get the same thing, or go ahead and do the entire problem and see how you did. So as I'm looking through the graph, I just went through and identified what the factors were at each one of the locations. So at x equals negative 1, I'm going to get x plus 1, but I see that it's bouncing, so it's going to be an x plus 1 squared. Then I have x equals 2, but that gives me an x minus 2, but then there's a twist happening there, so that's going to be x minus 2 cubed. And then I get x equals 4, which is x minus 4, and it's just charging right through this, so there isn't any type of multiplicity, so no exponent on it. Went ahead and took my factors, wrote them out, put the a in front, plugged in the numbers that I had, the 3, 3. Notice that I didn't force the a to come out to be positive or negative. I just plugged the numbers in for x and y. It went ahead and worked itself out. Okay, so now we've got some division problems on here. So I'm going to go through and do 2 of the division problems with you, and then again after 11 and 12, go ahead and pause it, see if you can get the remaining problems. All right, so we want to make sure that The x minus 4, so the thing that we are dividing by, is going to go on the outside of the boxes. So I'll do an x minus 4 on the left-hand side. I'm going to go ahead and extend my division. I'm not sure how long I need it to be, so I'm going to just leave it open. And then I'm going to take the very first one in the problem, and by the first one I mean the one that is leading. Therefore, even if it's not in order, it's the one that's got the highest exponent. So that's going to be my 4x cubed. My 4x cubed is going to be placed inside the first box. Then from here, my job is to kind of fill in the puzzle. So in order to get a 4x cubed, that's going to have to be a 4x squared. Now I'm going to multiply those to create that box, which is going to give me a negative 16x squared. Now I've got my x squareds. If I go back up to the question, I need to get a negative 11x squared. So I have to figure out what goes in that box to go with the negative 16x squared, and that's going to have to give me a 5x squared. So that when I add the two yellow boxes inside the division problem, I do get what I have in the question, the negative 11x squared. Now I'm going to divide again. So that's going to give me a plus 5x. Then I have to multiply to figure out what goes in the bottom box here. And the bottom box here is going to be a negative 20x. I'm now looking at the x terms. Go find the x term. I need a negative 28x when I combine the blue boxes together. In order to get the negative 28x when I add, that's going to be a negative 8x. Now I'm going to do my division. So this is going to give me a negative 8. Then I need to fill in the bottom box itself here by multiplying. So that's going to give me a positive 32 when I multiply. Then I go back to the question, find the constant itself, and figure out what goes there to get the 32. Well, I already have the 32, which is really kind of nice. And remember, that last thing is going to be your remainder. So our answer to this is whatever is across the top of the boxes. So the division answer is going to be 4x squared plus 5x minus 8. And there isn't going to be a remainder. So that's my answer to this question. Okay, let's move on to question number 12. I'm going to do the exact same thing. I'm going to take the stuff that is on the bottom, and that is going to go out in front. So I'll have my 3x plus 1. So those items go out in front. I'm going to go ahead and open up the box for the division. I don't know how long I need it to be. You can always erase it, or you can always extend it as needed. All right, now we're going to go through, we're going to find what would be the leading. In this case, it's already put in descending order, so it's going to be the 9x to the 4th. That's going to go in that first box. Now, we're going to go ahead and do the division. That's going to give us a 3x cubed. What we're going to do then is fill in the bottom box by multiplying, and that's going to give me a 3x cubed. Now, go back up to the question and find the x cubed term. I want a negative 3x cubed when I add the two green boxes together. Well, in order for that to happen, this is going to have to be a negative 6x cubed. All right, let's go ahead and divide to get the top. That's going to give me a negative 2x squared. Now I need to fill in the box below that here. So I'm going to multiply. That's going to give me a negative 2x squared. Okay, back up, find the x squared term. I need the sum of the two blue boxes to give me a 10x squared. So this is going to have to be a 12x squared. Now I'm going to divide. That's going to give me a plus 4x. I need to fill in the bottom box now by multiplying. That's going to give me a 4x when I multiply. Go back up to the question, find the x term, and know that the two purple boxes need to add together to give me x. So that's going to have to be a negative 3x. Now I'm going to divide. That's negative 1. I'm going to go ahead and fill in the bottom box here by multiplying, and that's going to give me negative 1 when I do so. And then from here, go back up to the question, find the constant term. Know that the two gray boxes have to total to give me that answer as well, and it looks like I don't need anything, which is kind of nice, and there's my remainder. So my answer is going to be whatever's across the top. So 3x cubed minus 2x squared plus 4x minus 1. There is no remainder, so I don't have to write the remainder for this problem. Why don't you go ahead and see if you can do question number 13. Okay, so in this case, it looks like I do have a remainder, which is fine. We just need to make sure that we practice how we write that answer. So we're going to do across the top 7x squared minus 8x plus 21. Okay, now let's take a look at the remainder. The remainder is negative 109, and then a remainder always gets written over what you divided by in the first place. So in this case, it's the x plus 9 that we put out in front, which came from the denominator. Okay, see if you can do 14. Okay, so this one got a little ugly, but that's okay. It wasn't too bad. So we end up with negative 2x cubed plus 2x squared plus x minus 0.5, and then now we've got our remainder. The sign on it is negative, so go ahead and write the remainder, and then just put the remainder over what we divided by in the first place. And what we divided by in the first place is the stuff off the left-hand side, so it's going to be 4x minus 5. And that is going to be our answer. Actually, those are our last two answers. Okay, calculating the roots of something. In order to be able to calculate the roots of something, we want to be able to identify what the p's and q's are. So this is where the rational root theorem comes in. So as a reminder, the p-values come from the constant at the end. So I would go through and write out that p is equal to all of the stuff that goes into 3. So plus or minus 1 and plus or minus 3. All right, now we need to figure out what the q values are, and the q values come from the leading coefficient of 2 in this case. So our q is going to be plus or minus 1 and plus or minus 2. Okay, so now all of our options here for rational roots is going to come from the relationship of p over q. So we've got plus or minus 1, and then plus or minus a half, plus or minus 3, and then plus or minus 3 halves. Okay, not too long of a list. Now my recommendation to you is we're going to go through and use the factor and the remainder theorem here to figure out which ones actually work. So I would take this opportunity now to figure out what h of 1 is. So I would go through, and everywhere that I see an x, I'm going to plug a 1 in, and I'm going to see if hopefully that gives me a 0. If it gives me a 0, then 1 is going to be a root. All right, so if we go ahead and plug it in, I will get 2 plus 3 minus 2 minus 3. And this one works out, which is really kind of nice. So I do typically like to check positive 1 and positive and negative 1 first, and so I like to check the integers. Then I'll go back and check the fractions if I absolutely have to. Okay, so if I go through, then that means that x minus 1 is a factor. All right, because x equals 1 is a root. All right, if x minus 1 is a factor, then that means that I can divide by it. So I would go through and I would take this x minus 1 and I would divide it into the h of x polynomial. Now I know that it's going to divide in evenly because I'm using the factor remainder theorem here to help myself out. If I go through and I divide this, then I know for sure that I'm going to get 0 simply because I got 0 when I plugged that in. Okay, so now the 2x cubed is going to go first. I'm not going to do as much of my highlighting here since the focus on the division was on the previous slide. So that's going to give me 2x squared. So there's a negative 2x squared. All right, go back up. I want a 3x squared. So I believe this is going to have to be a 5x squared. So that's a plus 5x, which means I get negative 5x. And I go back up, I would like a negative 2x, which means that's going to have to be a 3x. So that's going to be a plus 3. That's a negative 3. Really hope my constant is a negative 3. Good. So, and if it hadn't been, then that means that I did something wrong when I was going through and doing my division or when I plugged in the 1. All right, so now I've got whatever's across the top. So 2x squared plus 5x plus 3. All right, now from here, I'm going to see if I can actually factor this. So I don't have to continue with my division. It's not necessary because it's already in an x squared. That's something that I know how to handle from previous years of math. So I'm going to go ahead and take out the boxes, see if I can factor this thing out. So it's going to give me a 2x squared there and a 3. All right, if I fill this in, that's going to give me a 6x squared and then a 5x. I think I can do that. I think that's a 3x and a 2x. All right, doesn't matter where you put them, just put them into the empty boxes. And then from here, we're going to go ahead and divide. And then whenever you go through and do this division, just make sure that you're checking your multiplication there. So it looks like this can be replaced with an x plus 1 and a 2x plus 3. All right, so I want to calculate the roots of this thing. All right, so let's write out what I've got here. So the factors that I found, the first factor that I found was x minus 1. The other two factors that I found were x plus 1 and 2x plus 3 for my division. All right, in order to find the roots of this, I'm just going to take those guys, set them equal to 0, and then solve for x. So I would move the 1 to the other side, and that was the one I'd already found. Move the 1 to the other side. Okay, in this one I'm going to have to minus the 3, so that's going to give me 2x minus 3. So here's my thought process here. And 2x is equal to negative 3, which means I get x is equal to negative 3 halves. Okay, and there are my roots for this problem. Okay, exact same process on this one. It might be a little bit more of an exhaustive list just because the coefficient and the constant are a little bit bigger. My recommendation to you, though, is to go through the exact same process. I am going to check positive, negative 1, since that's my first knee-jerk reaction to check those. And then if they don't work, I'm going to check positive, negative 2. So why don't you pause and let's see if we can find the first one. Okay, so after checking positive 1 and negative 1, neither one of those worked. And I just went through to the next integer, so I didn't check the fraction. It could have worked with the half, I don't really even know at this point, but the 2 worked. So x equals 2 is going to give me a root, which I've already written off to the side over there in my column, which means x minus 2 is a factor. So now I'm going to go ahead and divide my x minus 2. Okay, went through and I performed my division. Thank goodness I got a remainder of 0, which is exactly what I expected. So now I have this new polynomial, which is really just a broken down version of the previous polynomial. So this is an x cubed. This isn't anything that I know how to handle from previous years, which means I need to continue with my division. So I'm just going to go back to the exact same PQ list, and I'm just going to keep right on going with where I left off. So I got that 2, all right, so I would check negative 2. If I check negative 2, I don't think negative 2 works. That doesn't give me a 0. All right, so then I would move on to 3, which is my next one, and 3 does not give me 0. Remember, all I really care about is getting the 0. All right, let's check negative 3. Negative 3 gave me 0, which is good. Okay, so now this gives me my next 0. So I get x equals negative 3, which means I have a factor of x plus 3. All right, we'll put this in the list. So I get x plus 3 and x equals negative 3. Now you're going to do your division again, except you're going to use the x plus 3. So the two green items are going to go together. So let's go ahead and perform that division now. Now we have another resulting polynomial from this, which is going to be our 2x squared minus 7x minus 4, which I highlighted in blue. This is something that we now know how to handle from previous classes, so go ahead and take this opportunity to factor this. Once we have that factored, now we can go ahead and add those guys into our list. So we'll get a 2x plus 1, but then if I solve, that's going to be negative 1/2. Okay, so that was one of our first fractions, which we should have been able to find if we chose to do it that way. And then x equals 4. All right, and the question asked us to find the roots, so there are my roots. And that should finish our video for Essential Skills Polynomials of what we've done so far this year in Integrated 3.